Organizations of all sizes are embracing AI as a transformative technology to power their digital transformation journeys. In this episode, we're going to be talking about the impact data has in scaling those AI journeys. Take a listen. This is a part of a series on scaling AI for organizations and teams, and let's talk data and its relevance to successful machine learning. In this episode, we're going to explore the following. Why is data critical for successful ML projects? What are some of the key challenges in scaling AI with respect to data? And what are some of the best practices? To discuss this today, I'm joined by Roey Mechrez, CTO and co-founder of BeyondMinds, a Tel Aviv-based emerging AI, enterprise AI company, and I myself work there and I lead strategic partnerships and business development. Roey, welcome.
Hi Ganesh, thank you for having me. Looking forward to our discussion.
Sounds good. So can you, let's get right into it, but can you start with a brief introduction of you, your background, and the company, of course?
Yeah, sure. So hi everybody, I'm Roey Mechrez. I'm today the CTO and the co-founder of BeyondMinds. I lead our research and engineering team, a group of talented people that are developing our amazing BeyondMinds platform that I'm proud of, and I'm proud of the team. So a little bit about my background. I did a bachelor and master's in biomedical engineering, shifted into the medical imaging domain and fall in love with computer vision. And since then, I'm doing computer vision for a living. After working for a few years in consulting, I was doing my PhD at the Technion and doing a lot of different computer vision work, published several papers, including in the topics of generative adversarial networks, similarity measures, template matching, super resolution, reconstruction, and more. And in the last 3 years, I have the luck and honor to work at BeyondMinds, and helping enterprises to bring AI to production faster, better, and with mainly to reach production. I think that's the element of BeyondMinds, and it could be super relevant to what we are discussing today.
Awesome. And Roey, tell me, during your free time, I'm assuming you actually build those fake videos and automatically auto-generating videos that actually have world leaders in it and stuff like that. So I'm assuming that's what you do on your free time.
So basically, the video that you're currently seeing is not me; it's someone else that is talking. It's just using a video of myself, so it's a deep fake. And no, I'm kidding, of course. But deep fake detection is a problem that we worked on in the past. And I think in general, making video and playing with all these amazing technology called generative adversarial networks is one of the most, most promising invention of the last 10 years.
Absolutely, absolutely. So let's start from the beginning. Let's start talking about why is data really critical for successful AI ML projects, especially at scale, right? I know most of the folks who are watching this are very familiar with what AI is and how data is actually critical as a critical ingredient for AI. But tell us a little bit about why do you think it's really that critical for scaling AI?
Yeah, sure. So let's start with the obvious, right? Machine learning is basically a data problem, right? AI or machine learning, I'm using these terms equivalently. But if you want to train a classifier, a predictor, a detector, you name it, you need data for sure to train these models. And basically AI and machine learning as it usually deploy and used today required a lot of data for training these models. I think what happened in 2012 when we started to using deep learning at scale more and more, and definitely in the last 9 years, is that people saw that more and more data is needed in order to generalize better and better the models. Take GPT-3 as an extreme case of amount of data that is needed. The model is so large with so many parameters that you need huge amount of data to actually train such models. And okay, we need more and more data, but do we also need more and more labels? So I think in the first years of AI, it was a lot about, okay, let's collect data, annotate that, and train using this human annotation. And I think still we have many, many different applications that's the main elements, that's the way that they're used. I don't know, take transcription, right? Text, speech to text, right? That's originally used by collecting huge amount of speech and manually convert that into text and then train models to do that. But let's take an extreme different case of super resolution, right? Adobe recently released their super resolution within Photoshop, and super resolution problem is today trained in a completely unsupervised way. That means, or self-supervised way, basically. That means that you don't need any human annotation in order to train these models. Basically, if you want to go into the technical areas, so you take a high-res image, you manually or synthetically downgrade the image into low resolution, and then you try to reconstruct it. Right? I don't need human annotations. I can basically take infinity amount of images and just build model from that images. Now, I think these techniques are expanding more and more, and the ability to build what is called self-supervised representation is super interesting. It's one of the main research topics today in industry, in the academic community as well. Few-shot learning, semi-supervised learning. I think all these areas that we can, of course, discuss technically wise very, very deeply enable us to train and build very successful applications with limited amount of labeled data. And if you want to take, I don't know, you mentioned scale, right? So I think if you're not bounded by collecting huge data sets and annotate them, that means that you will be able to use large variety of applications organization-wide at scale without the need to record millions of images or millions of text or millions of data, right? That's open up a whole world, right? Anomaly detection is an unsupervised problem by definition. Different classification elements can be done today with limited amount of labeled data, etc.
So you're saying, and if I understand that right, like there are two classes of problems. The class of problems that you obviously need a lot of data and you can't get away with it, and you need a lot of annotation that needs to be done, which would at scale require you to have very deep data management practices and years of maturity to go do that. But then there is an entire other class of problems and techniques like self-supervised learning, super resolution problems, where you can actually do it with that and other techniques where you can do it with lesser amount of data and you can really go fast with deep learning.
Yeah, so it's a good question. So the answer is yes and no. So you can divide that as you mentioned, and let's take, for example, if you want to automate your claim assessment in an insurance company, right? You don't really need people to annotate data, because you can take all the historical data that people already annotated, right? Take the last 5 years of claims, that's probably millions of claims in a large insurer, and you just have infinity amount of data. Continue to annotate, continue to just train something that is mimicking this effort, and you will have a great solution. That's a completely supervised problem. But what if I tell you that now a pandemic is about to start, a completely, imaginary story. A pandemic is about to start, and the way claims are done in medical, whatever, insurance, is going to completely change and drift. Is your model that was trained on years 2015 till 2019 will work? and if will it be degraded, how significant it's going to be, and okay, even if you know that it's now degraded, what are you going to do? Because you don't have annotated data suddenly, right? It's a new type of claims. How you're going to do and if you want to go into scale and production, you have the system in production, you have the model already running, you already cut the claim into you shifted the claims into an automatic process. What are you going to do now? Like a year after you started and you are super happy with the solution, you have a shift in the data. And I think these are the challenges that today production is talking about when it's discussing data. How to handle data drifts, data changes, environmental changes, new type of data, new type of classes, new type of labels that are coming into production. And the same can go in a completely different domain. So I don't know, let's take defect detection in manufacturing. You train the models, you are happy with the solution, you annotated millions of images, you put that in production, someone changed the light bulb in the production room and the images look different. So what you need to retrain, to recollect data, etc. So these are super interesting challenges for scale.
Interesting. So from, break it down a little bit more for me. When you go from a lab environment where you have a data scientist in a Jupyter notebook, they get some CSV file with data, there's a lot of clean annotation, they train the models, they put it in production. Where's the real world? You kind of touched upon this a little bit, but what are the structural issues with respect to the model itself is trained with some set of data, and usually that's more sterile, that's more cleaner and stuff. What kind of packaging is done today of that data set to go and make it successful in production, and what are people going wrong with that?
Yeah, well, so you are touching one of the deep problems currently in AI, I think. This shift from lab to production, I would even risk myself and say that this is the problem of AI in 2021. I think that's what holds the entire industry back. And if you go to recent surveys that were published, we're talking about 10, maybe 15% of success in doing this transition from lab to production. And take into consideration, I don't know, an average $50 million spent on AI in a large corporate in the US, in the Fortune 1000 or so. That's a lot of money that is spent on amazing teams, lots of talent, lots of of infrastructures and business cases and work that is not reaching production. So that's a massive problem. And when it comes to data and this type of problems, and I started to touching that in the previous question, I think that's part of what holds the industry back, right? If in the past we talked about lack of talent, strategy, vendor selection, where to start, etc., I think today we're talking about challenges and barriers in the technology area, how to handle production, how to handle scale, how to handle shifting in the data, how to monitor problems, how to train solutions over and over again in production. Take a recommendation system in Netflix or Spotify, for example. Every TV series that you now will watch on Netflix will trigger a training element for the recommendation system, specifically for you. That's like a massive scale of training that is done in production. Now, of course, Netflix is first a technology company, but how the entire industry, insurance, oil and gas, finance, manufacturing industry, whatever, are going to handle such complex models, right? It's much more than training a model. It's way more complex. It's a complete system that have ability to handle noisy data. Okay, that's another topic, by the way, relevant to data that need to be addressed. You're going to have in production different data from what you had in the lab, for sure. That's like the most basic assumption that must be done. If you took a data set, you train a model in the lab, when you're going to move to production, something is going to change. And even if the lucky case is that it won't change, it will change over time for sure. And you're going to have I don't know if it's an NLP case, you're going to have slang and noise and typos, and I don't know, you're going to train a model in English and you're going to get input in Spanish. You need language detectors, etc. It's a complete system that need to wrap these models to really be success in production, and definitely relevant to everything around data.
Interesting. Like one thing I have actually noticed is, people traditionally coming from the big data background or just data management background try to address all of these problems from a perspective of how do I make sure that data, which is residual, or meaning either it's stored somewhere, it's organized in some way, the ETL frameworks that they have, they're trying to solve all of these characteristics on getting the data ready or prepared for doing ML and AI systems. The problem, with that approach, while that approach is necessary, it's not sufficient for successfully scaling AI. You need to look back from the ML side and say, what kind of ML techniques do I have to put in play in my AI systems? And you took you mentioned a few examples, and just for everybody's benefit, I want to pick one or two and just go a little deeper, right? One is you talked about the whole notion of learning the drift in the data that's actually in there. So that you and I were talking about defect detection earlier, and if you're looking at a scratches on a PCB device or like on a screen, scratches on a screen as an example to look for, there is not enough data set you can actually collect to get all the possible combinations and variations of those scratches to detect it. So you need to have a different approach to that from the ML side to look at scratches. The scratches may not look alike at all, right? The noise levels are going to be higher. The signal to noise ratio is going to be pretty low. And then the drift, like the NLP example that you actually did. So talk a little bit more about specific approaches in that space, right? From the ML side, that models can be put in play, like and go a little deeper if you can on the ensemble approach to it, right, to doing that versus just using a machine learning model.
Definitely. So first of all, let me start with a simple mechanism that I think is very, very helpful. And if you want to learn more about that mechanism, I gave a talk at NVIDIA GTC a few weeks ago exactly about that problem. And I have a talk for it. It's also available on our website or on YouTube. So the problem is the garbage in, garbage out problem, which is a very classic software problem, right? If garbage will come in, garbage will come out. And I think I gave in the talk a quote from the first computer ever invented, and I think they already noted the problem of garbage in, garbage out. And definitely that's a very strong problem in AI, right? I like to call it the giraffe problem. So think about the simplest classifier that you can ever think about that's built to distinguish between cat and dog, right? I think today you probably can achieve 99.9% accuracy to distinguish between dog and cat. Okay, and you put that in production, not sure why and for what application, but let's assume that. What will happen if you're going to get an image of a giraffe, right? Mm-hmm. And the basic answer is that it will classify that as a dog, and in the worst case, as a cat. And even to make it worse, if you will look at the softmax or the probability basically that comes from the deep learning, from the neural network, it will say that it's 99% sure or 95, I don't know, 90%, 80% sure about that classification, right? And it's connected to a very simple problem in AI. When it fails silently, right? You won't know that it fails. You won't know that a giraffe came in. Okay, now, given that problem, what can we do in order to make sure that in production, we will be able to stop these giraffes and stop them from coming to the model? And I think the recent year or maybe a bit more, one of the emerging research problem is out of distribution detection, right? Clearly, when we trained the model, we had a distribution, and clearly this giraffe is out of the distribution. Can we detect out of distribution detection? It's also very, very relevant to generative adversarial networks. Like the basic idea of generative adversarial networks is to train as a min-max game between the generator and the discriminator. And basically what happened during this game, the discriminator is trying to understand what is the distribution of the data and be able to say, wait, this is out of the distribution. And of course, there are many other mechanisms that can be thought about in order to build such a garbage collector to defend the model. And that's super, super, super important to be able to screen the data that comes in. And if you go into mission critical, last mile, sensitive applications, where we can assume that in most of them we have a human in the loop case, that's even more important, because you want to make sure that these anomalies, these out of distribution cases will go to a human because they are different. And connecting back to the story that I gave about the hypothesis pandemic that is approaching, that's exactly what a good system can do in such case, right? And if you want another mechanism, so one of the great research topics in the last year or two is uncertainty estimation or confidence estimation. I think it's more intuitive. It's the ability to say with better ability what is the certainty of the model in this case, right? Okay, we got an image. How sure are you about this classification, Mr. Model? And in most cases where data is drifting slowly, I think that's super important, because you will see that the confidence is dropping, right? And you can build you can use MC dropout, for example. I think this is then one of the simplest ways of incorporate confidence, or you can build an assembly of models and be able to, think as a group and look at the mutual agreement of models, as a roughly ideas. And then to improve generalization, you can use severe augmentations and semi-supervised techniques that can improve your generalization of the models. Like, okay, you have your data set, but let's try to push it to the extreme, right? So using extreme augmentations. So I think augmentation is one of the most common techniques to improve generalization, and people are using, rotation, scale, and crops of images for a long period of time. But can we take that to the extreme and really use techniques like consistency regularization in order to make better models with severe augmentation, etc. So there are many, many different techniques in order to build more robust, stable. I think stability is the name of the game here. You want to have stable solution, sustainable solution as well over time, and what is required from an AI system to do so. And if you want to connect to the previous questions that you asked about the production gap, so I think one of the gaps as a high level is exactly that, the understanding that in production you need to understand all these requirements, but you're going to need to build a system, not a model, not a classifier, not a detector, a system. And a system has many, many different components that need to be addressed.
Understood. No, I think, and if I might summarize that, so and we talked more on the data challenges are pretty grave in deploying ML or AI systems at scale. And you actually talked about it in a few different ways, from what can you do from a best practices perspective, right? One is the garbage collection problem, like the giraffe problem. How do you solve it? By just looking at or applying ML techniques to look at incoming data to say whether they fall within the distribution versus not. We talked about confidence estimation to look at the certainty of the prediction that's actually being gotten and using that as a guiding metric. Stability being the name of the game, and actually how do you keep the environment stable? And you were actually going into this, which is you have to look at this as an AI system rather than an ML model. So what kind of management and operations infrastructure do you need to actually put in place to go make this happen? So, give me some examples. My last question to you will be more like, give me some examples of organizations that are getting this right. Because, before you answer that question, one of my hypotheses personally has been AI has a 1% problem, wherein you're not Google, you're not Facebook, you're not Netflix. You don't have the army of researchers, you don't have the army of ML teams, you don't have thousands of data scientists to actually go, perfect and build your own specific AI system. So most organizations are stuck with, ready to use tools everywhere and teams that they can hire. And talent is a different problem and all that too. So, but give us some examples beyond the top, the FANG, players, right? Regular organizations who are putting this in practice, and talk a little bit about how BeyondMinds is also helping them do that.
Yeah, for sure. So one comment about what you said. So I think talent is an issue, but not in the terms of, okay, let's bring lots of PhDs from Stanford and MIT that graduated in AI, because that won't help you bringing solution to production. That will help you building the models, which is also important. It's part of the job. But to productize that, that's a completely different story. And I think although the academia part is doing a great work in bringing more and more talent into the market, it's the industry responsibility to train and build mechanism to train these people on how to bring solutions to production. And that's a lot of engineering and infrastructure. And I think in general, AI is about infrastructure problem, right? It's a corpus. It's a system. It has many different components besides the model, which is the heart of the system. But it's only one piece of the puzzle, right? And it's like saying that, okay, the engine is the most important part of the car, right? Okay, you try to drive without wheels. And confidence estimation and screening the data and auto distribution, and to add to that, monitoring, retraining. I like the term evergreen AI, right? AI is very data depending. The data is going to change. You want to make sure that your AI will be on the rails, impacting over time. What is required from your system to accomplish that? And I think, it's not necessarily about talent, because I met, one of the largest bank in the US last month, and one of their technology team member told me, we have like 1,000 people in the AI ML team. And I think it's true, right? They probably hired like crazy the last few years. But what is their success rate in bringing AI to production? It's still 10%, right? And Google's and Facebook and the Amazons and the technology company, their success rate is way over that. It's not because they have better AI talent, maybe as well, but they have amazing engineering environment and the way of taking solutions again more and more and more and bring technology to production, and that's a completely different story. So that's the name of the game here. Besides stability and system, relevant to building a successful throughput in AI, is about infrastructure, right? How you build a scalable way and set of tools and team members, etc., and process of bringing AI to production. You need ML ops, and you need monitoring, and you need the ability to handle noisy data, and you need not to do POCs. You need to focus on production requirements, and you need to have good connection with business, because bringing AI to production is a lot about getting business decisions, right? I can give you an example. So let's assume, back to the claim automation process that I gave earlier today. So I want 99% accuracy in claim automation, 99% precision recall, okay? Not achievable. No matter what, how much data, how many research, bring all the talent and all the state of the art, you won't get 99 precision recall. What are you going to do? And it's a lot about business process, right? And the right process for that, for example, is having a confidence score that will be good enough in order to threshold and divide the claims into two buckets. That's going to be automated because I have high confidence, and that's going to be manual work, and the human in the loop is going to process that because I have low confidence. And in the area where I have high confidence and it's within the distribution, it's in the repetitive cases, and it's probably 80% of the work, I can achieve 99% accuracy. But I need the business owner, and I need to understand the business process, and I need to get this decision right. So I think that's part of the game. Building infrastructure, investing in platforms, in tools. Don't be shy of using external vendors when needed. I think buy versus build strategy is one of the important way of winning this game. And same as software goes with AI, right? Nobody is thinking about building a CRM internally these days, right? But if you go 20 years ago in the 90s, so many large organizations tried to build their own CRM and invested probably $10 and millions of dollars on developing that. And today, all of them are, I don't know, using off-the-shelf CRM that is specialized exactly for them. And there are vendors that offer exactly that in AI, and of course, BeyondMinds is one of them, and that's exactly what we're doing, and that's I think an important
Awesome.
point.
Here's a bonus question. Tell me your most fun customer that you worked with who solved this particular data problem, and give me a very quickly specific example in a very creative way.
Wow,
I'm sorry.
That's a good one. Okay, I need to think about that. For example, yeah. So I don't know. In the won't dive into the specific case, but when you do face recognition, right? You want to be able to detect fraud cases or anomalies or spoofing, what is called, right? I can take my phone and show a picture of someone, and I don't know, is it going to open whatever to do face recognition? So I think this type of fraud and having a back office of human in the loop, if you want the right accuracy, you must have a back office, and you must be able to cut the pile to what is automating and what isn't. Otherwise, you can't reach the right accuracy with the right sensitivity, etc. So I think I can think of many examples that we done and work like that. But I think face recognition is a good example for that.
Awesome. No, thank you, Roey. This was extremely informative. I'll add some bunch of things that you talked about in the show notes too, so people can go and research more and know more about it. I like to actually say, right, you touched upon many things, right? We started with data and the challenges with respect to, environments that are purely just, isolated, incubated pilot environments to really running things in production. It gets hairy, it gets challenging. You shared some best practices and what are the ML approaches that you can use, and how do you really, you wrapped it up with saying, like, how do organizations think about, engaging with partners, the approaches to go doing it, investing in platforms and practices and so forth. So I think it was a very, there's a lot to digest in this session. So thank you so much for spending the time today. And I look forward to continuing this conversation. There's so many things out here in this conversation that can make itself like a deep episode that we just go deep in and get lost in that particular journey. But thanks so much for spending the time today. And any last words from you?
No, I think thank you for having me. I think it's exciting times in the AI community, and hope to see better success rates in productizing AI soon. I think it's an amazing technology, one of the most amazing technology the man ever created.
I agree, and I like to always say that, like, there is a PwC claim that did the study. There's a $13 trillion opportunity in GDP improvements by 2030, and it's it's in all of our hands as practitioners, as people, and folks in the AI space to not F it up and really just, rise to the occasion and get things to production and make it working.
Yeah,
So
definitely.
thanks
Let's
so much.
fulfill this profit.
Sounds good. All right, Roey, thanks a lot.
Thank
Have
you,
a good
Ganesh.
evening. Talk to you soon.
Thank you, soon.